Hi, this is Kevin Trainer, and I want to welcome you to my tutorial on physical data modeling part 5. And when I started this, I said it was going to be a 5-part tutorial, and it's already up to 6. And I think I warned you at the beginning of the last one. What we're doing here is that we are improving the data model to make it conform to the expectations of a data model for a relational database. And some things that we've done so far is we've picked data types for the columns. We've made sure we had the right primary keys. We've made sure that we had associative entities or tables in situations where we had a many-to-many relationship. And then we started on the normalization, which is a way that we get rid of redundant data. And the first part of that is sort of easy. You get rid of repeating attributes, columns, or repeating groups of columns. And we did that in the last part. And so now we're on to normalization more generally. And you can really go about this a couple of ways. The classic way that you do is you learn about these rules of normalization. We have these kind of standards for goodness of a data model called normal forms. And you learn them kind of one at a time. First normal form, second normal form, third normal form. We typically want you to get your data model into third normal form. There are higher normal forms, and there are people who use them, but the first three are the ones that are probably most worried about in database design for online transaction processing systems. So we can either talk about the normal forms until we're all asleep, or we can try to come at it another way that I like to, which is when we have follow the rules of all the normal forms, what's the result that we want? And the result that we want is that all the data is on the right table, okay? And there's no redundant data. So here, what we're looking for are columns that we've put on the wrong table. And I can also see that I didn't give a data type to the columns that we just added in the last part. So we're going to have to do that. In fact, why don't we do that while we speak? So we're going to give that an attribute. So user ID and role ID are both ints. And let's come down here and show attributes for that. And role ID can be an int, but role name is going to be a varchar. So that's all done. All right. No harm, no foul. Okay. So we want to make sure that the attributes are columns and the relationships are placed on the correct tables. Okay? If we put it on the wrong table, it can just cause a mess. In general, when you have it on the wrong table, it causes you to put redundant information into the database. Okay, that's a side effect of having the column or the attribute on the wrong table. Having the same attribute on more than one table, same problem. Okay, redundant information. Okay, so let's go and try to fix a couple of things. Okay, so one thing that I intentionally left broken was here in course offering. Okay, I've got I don't have a semester table. Okay, so I'm going to have to add back a semester table. and I haven't had that so far. Okay. So what do I want to do? Well, if I have a semester table, it's going to have a key of semester ID. Okay. It's probably going to have a semester name. All right. So having them on the course offering table, I'm going to have to code a semester name over and over again. That doesn't make sense. Right? That's going to be redundant. If I have 3 course offerings for a semester, spring 2016, that spring 2016 is going to appear 3 times in the table. We don't want that. So we're going to create a new home for it. So why don't we pull out another entity box. Okay. Or table box, as we should probably be calling it now. Okay. And let's call that semester. Okay. And let's see that it has a key of semester ID. And the other attribute is semester name. Okay. And it doesn't have any other attributes that I'm aware of. So sometimes you have to work at it to get something selected. So we want to cut off that last attribute. Okay. And then we're going to have a relationship between course offering and semester. So let's see. One semester has many course offerings. One course offering is for one and only one semester. So let's pull out a relationship and hook up the many side to course offering. Okay, that's good. And then let's hook up the one side to semester. And that's good. And we're crossing some lines here, which we don't like to do, but we're going to do right now. And let's say has offering. Okay. So a semester has an offering. That's a course offering. Okay. So I think we have what we need there. And we need to get the column types. So show attribute types. Semester ID is an int. Semester name. Well, I think that's a varchar. We said it was before. So let's get the gray box around that and then type in varchar. Okay. And then let's get the redundant attribute off of, let's get it off of course offering. Okay. So now that looks a lot better. Okay. So, was this a violation of second normal form or third normal form? Golly, one of them. All right. I don't know why this is behaving so badly. Let's redo this. Okay. I'm hoping that if I back up and connect this, I'll be okay. It looks okay, but I don't know why that wants to go there. Sometimes this draws so badly. Let's back up again. Has offering. So I'm going to just try it again. It doesn't want to cross the lines. That's our problem. So why exactly it's going to do that, I don't know. Let's put it right there. It really wants to put it there. Okay. Well, I'm going to have to fix that later. Okay. So we fixed that. Has offering. It's drawing the line kind of oddly, but I'm going to fix that when I'm correcting my artwork. I tend to correct the artwork last. All right. And okay, so we fixed that problem. Now let's look at some other problems. Let's look at these kind of one by one. Okay, let's go up and see student. Don't see any redundant information there. Instructor. Don't see any redundant information there. Registration is just a associative entity, so I don't have to worry about that. Course offering. Well, the course name goes with a course offering. Course location goes with the course offering. Days and times. Now, I could make improvements here. Okay, so what kind of improvements could I make? Well, for instance, it's probably true that every course of the same number has the same name. Okay, so probably what we want is we probably want a course table. Okay, so when you use a number, you get the proper name for that course, because that's really redundant information, and we've got it here and it's uncontrolled. So how would I do that? Well, again, I would pull another box out, and I know we're getting crowded, but let's say that this is just course. Okay, and that's going to have a course ID. Okay, and it's going to have a course name, and it's not going to have another attribute, so we can get rid of that. Sorry about that, guys. Published the last of them to the last of the videos to YouTube. That's what you see coming up. And let's try this again. Attribute name cut. All right, so now that's gone. All right, and then let's see. We have one course can have many course offerings. Okay, and each course offering is for one and only one course. So let's get the relationship. Hook up the many side to course offering. Okay, hook up the one side to course. I don't know what happened there, but nothing good. Let's see what it thinks it's doing. So let's highlight that relationship, and let's try to come over here and see if we can make that work. It's doing a little better there. Okay, and course offering, we might call it maybe offering of. It's an offering of a particular course. Okay, now we take the course name out of here and we've gotten rid of redundant information. Now, we've done two things, right? One is we've gotten rid of redundant information, because if we've got 3 of the same course that we offer in the same semester, they're all going to have the same course name. So that's redundant information we've gotten rid of. The other thing is we control the values. So let me get rid of the redundant information first with a cut. And controlling the values is really important. Okay, because let's say we have 3 courses of systems analysis, course number 340. We don't want it to be called systems analysis in one, system analysis in another one, sysanal in the third one. We want to control the values. So using a relationship to a table that just controls the values for course names gets rid of redundant information, improves the integrity of the database, and it's very much in the spirit of relational database design. Okay, now what else do we need to do? We need to give these guys types. So let's do that. Sorry, you have to highlight the whole thing, right-click, show attribute types. So course ID is an int, that's fine, and course name is going to be a varchar. Okay, so we solved that, and we got rid of that. Now, course location, all right? We could get rid of redundant information there too. We could have a table that had every possible location in it, say every classroom that we could teach in, okay? And we could have we could pull this out and have a location table, okay? But we're not going to do that. So we're going to allow course location to be free-form text and days and times to be free-form text. Is that as normalized as it might get? No, it could get further normalized, all right? But we're thinking that for our design right now that's normalized enough. So we're okay down through course and course offering, class meeting, we've got the password, the instructor name. We don't need the instructor name. How do we get the instructor name from a class meeting? Well, how we would do it, if we want a class meeting, we would chase down the relationship to sorry, we're on a class meeting. We're going to chase down the relationship to a course offering, and then we're going to chase it over to has instructor, and then we have the instructor name. Okay, so we don't want redundant information here. So instructor name is gone. Get rid of that. Cut that. And the same thing for course name. What if we want to be able to print out the course name when we're looking at a class meeting? Well, again, we chase the relationship between class meeting and course offering, and then we chase the relationship between course offering and course, and we come up with the course name. Okay, so let's get rid of that. Now, I've got to say that for some people, this kind of process of normalization kind of chops things up a bit. Okay, so you wind up with a lot of tables, a lot of little tables, a lot of these tables that historically I call lookup tables. Okay, what's a lookup table? Well, it's just an ID and a name. Okay, now the reason why it's good to have these lookup tables is that it squeezes redundant information out of the database, makes the database smaller. It reduces the chances that we'll have conflicting facts, okay? And it controls the values. Okay, so if you look at the lookup tables that we have, roles, a lookup table, it controls the values for roles, okay? Course is a lookup table. It controls the value for courses. Semester is a lookup style table. It controls the values for a semester. So not only do you reduce the space requirement, you eliminate redundancy, so you can't have conflicting facts in the database, and you control the values, which is a very important thing to do. Now, typically we would look for one other kind of opportunity for normalization, and this is one that I didn't seed into the model, so I can't show you an example of it. But another kind of redundancy that you can have is that you've stored something explicitly that you could have calculated from other values that are in the data model. The classic kind of situation is where Oh, let's say we have an order processing system, we have an order, and we have all the facts in the database where you can add it up and see how much the order is. So you could add up all the items and the quantity. You could multiply that out. So you'd have an amount, and maybe there'd be an amount for sales tax, and maybe there'd be an amount for shipping. And then the question is, are we going to store the total amount in the database, or are we going to recalculate it every time? If you follow the hardcore rules of normalization, you'd say, well, that's really a redundant fact, okay? And the fact is, if you store a redundant fact, it can then become inconsistent with the other facts that are in the database. So if you're going to do hardcore normalization, you would not store the total. People sometimes have to denormalize their models, either for performance or convenience, in which case you will find people kind of dialing back off of that decision and maybe storing the total in the database. But what I look for from my students is to completely normalize the database to this third normal form that we've been seeking. In which case we would not store a total because it could be calculated. And if we decided that we were going to store it at a later time to denormalize the database, that would be a later independent decision. So that's it. I've got my physical data model. I'm pretty close. I don't have any foreign keys yet. Okay, and I've got some improvements to make in my artwork. But apart from that, I'm just about done. So I'm going to say bye until we come to part 6, where we're going to be talking about foreign keys. Bye for now.